Welcome to solverfy.
Problem we want to know how much current is carried by the beam in the Tevatron. At the energy of 1 TeV, the protons are moving practically at the speed of light. So from uniform circular motion, we find that the time for the protons to complete one revolution of the ring, then the total charge that passes any point in the ring during that time is the charge of the entire group of the stored protons. Then the current is then the total charge divided by the period. So we have mu is equal to 2 pi r divided by the period. So the period, the velocity in this case is c. So the period is just 2 pi r divided by c. And then the current is the number of charge that we have divided by the period. And then the period we can write in terms of the radius. So n is c divided by 2 pi r. And we can write the values for this. So we have 5 times 10 to the 13 protons. And the charge for each proton is 1.6 times 10 to the minus 19 coulombs. And then the velocity is 3 times 10 to the 8 meters per second divided by 2 pi and the radius of 1 kilometer, 10 to the 3 in meters. So the current is 0.38 ampere. So for part B, how fast will be 1,500 kilograms car to carry the same kinetic energy of this beam? So we have 1 TeV. So we want that the kinetic energy of the beam is equal to 1/2 m car v car square, and then v car is equal to square root of 2k beam divided by the mass of the car. And then we can use the values to see what is the thing. We know that the kinetic energy of the beam is 1 TeV, and we have 1 TeV for each proton, so we have to multiply it for all protons. So we have how much energy each beam has, 10 to the 12. How many protons we have? 5 times 10 to the 13. And the conversion to joules is 1.6 times 10 to the minus 19. And then the mass of the car is 1,500 kilograms. And then the velocity is 103 meters per second. So it's not that fast. But we have to remember that this energy is concentrating in a really small area, where the kinetic energy of the car is spread across a much larger area.